Flow rate is defined as the volume of fluid flowing through an area each second. Stream flow rate is important because of the impacts it has on water quality and on living organisms and habitats in the stream. Larger, fast-flowing rivers can receive pollution discharges and not experience as severe effects, whereas small streams have less capability to dilute and degrade waste. Stream velocity, a component of stream flow, determines the kinds of organisms that live in the stream. For example, some animals need fast-flowing areas, while others live in quiet pools. Flow rate can also affect the amount of sediment carried by the stream. Sediment in a slow-flowing stream will settle quickly to the stream bottom, while sediment in a fast-flowing stream will be suspended longer in the water column. Additionally, fast-moving streams generally have higher levels of dissolved oxygen as compared to slow streams, because fast-flowing streams are more aerated. The following example demonstrates the simple way of measuring flow rate in a stream.
Today I'm going to show you how you can measure stream flow with a few household objects. First, you're going to need some twine or some string. You're going to need a measuring tape and a buoyant object like a piece of fruit and a stopwatch. So the first thing we're going to do is we're going to set up our string or twine or rope or whatever material you have. And you want it to span across the entire stream. And you want two sides of it because this is going to block off your area that you're measuring the flow in. So I just tied it to some sticks, but I tried to make it pretty parallel. So now that our twine is all set up and our area is established, we're going to take our object, like our piece of fruit, I have an orange, and I'm going to let it flow from one side of my twine to the other. And I'm going to time how long it takes. So I'm taking my buoyant object, I'm going to drop it on the outside of my twine, and I'm going to start my timer when it is directly under this side, and I'm going to end it when it's directly under the opposite side. And that's how much time it takes for my orange to get from point A to point B. Alright, so that took roughly 9 seconds. I'm going to repeat this process after I get my orange, and I'll take an average of those times for my time in my flow rate. Okay, so now I'm going to use my tape measure to measure the area of my stream, this cross-sectional area here. So first I'm going to measure the width of the stream, and then I'm going to measure the distance between my two pieces of twine. So now I'm going to take a few depth measurements so that I can take an average of them and get an average depth. So that way I can find a volume and then divide by the times that we have. So now that we have our depth measurements, we have our two measurements for our area, and we have all of those time measurements for our object to float through. I'm going to show you how you can calculate flow.
On the right side of the screen, you can see a list of our field measurements. The equation we are going to use to calculate stream flow is flow rate equals length times width times depth divided by time. Length times width times depth is the same thing as volume. The first thing we need to do is determine our average depth and our average time. The average depth was found by adding up all of the depth measurements and dividing by the number of measurements. The average depth was found to be 3.17 inches. Similarly, the average time was determined by adding up the time measurements and dividing by the number of measurements. The average time was found to be 9.05 seconds. The next step is to plug our values of length, width, depth, and time into our flow rate equation. After subbing in our known values, we can now calculate the flow rate. Our flow rate was found to be 3,606.4 cubic inches per second. which is equal to 2.09 cubic feet per second.